In Precalculus section 2.4, I've split it into two sections. So we're going to have a 2.4a video and a 2.4b video. So we're dealing with zeros of polynomials. Now this question is very similar to what you did on your prior test, which you should have done a guess and check in order to solve it. But there is a method in this section that we can use to solve it. So the water level in a bucket sitting on a patio can be modeled by this equation, where f of x is the height of the water in millimeters and x is the time in days. On what days will the water reach a height of 10 millimeters? So, I need to know when this equation equals 10. So what I can do is I can subtract each one by 10. So I end up with x cubed plus 4x squared minus 2x, and then 7 minus 10 is negative 3 equals 0. So this right here is the equation that I want to solve. Now, neither of the methods I use for you to manipulate it, turning it to use. Now solve this. I cannot use what I used before in the methods that I gave you before, but I need to break this down. So I'm going to graph it to find at least one where y equals 0 and see if I can make it into smaller factors. So I've graphed it here, or I've put it in the equation on the y equals, and then I'm going to go to second table. And I'm going to find when y equals 0. So if I look at here, y equals 0. And so one of the solutions is when x is 1. Right? So that means one of the factors should be x minus, minus 1. Because if this is positive 1, then my x minus c says that this should be a factor x minus 1. So let's use synthetic division to check it out. I have to have a remainder 0 or else it's not a factor. So 1, 4, negative 2, negative 3. Bring 1 down. This is 1. I'm adding here, so 5. 5 times 1 is 5. Negative 2 plus 5 is 3. Then 3 gives me 0. Right? So this is in fact, because it's 0, this is in fact a factor. So then that means the other side is x squared, 1x squared, plus 5x plus 3. So with this, now I can factor, and this is equals 0 of course, I'm continuing. I can factor this. I can bring this down. And this is stuff that I've learned in the prior section. So I just take this and I factor it. So two numbers plus 5x plus 3. I plugged it into the quadratic equation because I couldn't find two numbers when multiplied together gets me 3 and two numbers when added together gets me 5. So when I plugged it in, I got this. So negative 5 plus root 13 over 10, and then negative 5 minus root 13 over 10. That would give me the two remaining factors. But it's asking for time in days. So my options are numbers 1 through 7. Because these would be decimals, it doesn't matter if I solve it or not, it would be neither of these. So I would do x minus 1 equals 0. And then I'd add 1 and add 1. Because remember, days can't be negative. So if I end up with a negative number, I also couldn't choose that. So I end up with x equals 1. So on day 1, it equaled 10 millimeters. So it's not asking us to solve it. So even if I didn't finish that part, that's fine. It's just to find that day 1. Okay, and eliminate all the other options. Sometimes they'll give you negatives, and days can't be negatives, so the stored problem helps you eliminate all the problems. Because in this case, because of this, we have 3 zeros to choose from. but only one fits this criteria. So go ahead and pause and write this down. We're going to do one more board. On this board, we're dealing with the fundamental theorems of algebra. Fundamental theorem of algebra. I went over it with you in class because I kind of exposed you to it already. And basically, that just means that the root here tells me how many zeros. The power here, the leading power, tells me how many zeros there are. So this one has 3. Some function of the least degree with real coefficients in standard form that has -2, -4, and 3i in it. Now, it's supposed to be a 3. 3 minus I. So when I can repeat there's equations that have all 3 of these and then repeats, but we're looking for the least degree. So we're assuming that these are all of the zeros, -2, -4, and 3 minus I. Now, dealing with I, there's a theorem you're going to learn for the second part called complex conjugate. And basically what that means is that if 3 minus I is a 0, then its complex conjugate, which is its opposite, 3 plus I, is also a 0. So I'm going to plug this in. This tells me that I'm dealing with this x minus c, and these are all my c's right here. This. So we have x minus -2 times x minus -4 times x minus 3 minus I, and then x minus 3 plus I. And then I can go ahead and multiply x plus 2, x plus 4, and then x minus 3 minus I, and x minus 3 plus I. So to save time, I've multiplied these out to you. This is actually going to probably be the longest part of your assignment, is to multiply this all out. Since we've done it in so many videos in the past, I've just done this. Remember, every time you end up with an I squared, you end up with a negative, and eventually the i's will fade out of the equation once you do multiplication. But we'll go over a long one in class. I just don't want the video to be too long. But once I have these multiplied, then I can multiply these out. So I have x squared minus 6x plus 10. Then we have -2x, x squared minus 6x plus 10, and then -8, x squared minus 6x plus 10. So with that, then I multiply it out. We have x to the 4th minus 6x cubed plus 10x squared, then minus 2x cubed plus 12x squared minus 20x, and then -8x squared plus 48x minus 80. This is supposed to be 80. Sorry. Let's put it here. Okay? From here, we just combine like terms. There's no x fourth, so I'm going to bring that over. We have a -6x cubed. Please make sure to underline so you know you've covered everything. Minus 2x cubed would give me -8x cubed, and I think that's it. We have 10x squared, 12x squared, which is 22x squared, minus 8x squared, which is positive 14x squared, and then -2x, 20x, and positive 48x gives me a positive 28x, and then -80. So this, if I factored it, should give me this right here. And the next section, I'll show you how to go from here to here. But this is the polynomial with least degrees with all of these as your zeros. And that would have been a lot longer if we had worked this whole thing out, but we'll go over it in class. Go ahead and pause and write this down. Try your guided practice 3A and 6A, and I will see you in class.